Good morning everyone, we are from tutorial group 4. Today we are going to present tutorial 12, which is chapter 13, correlation and linear regression.
Question 1. An auto manufacturing company wanted to investigate how the price of one of its car models depreciates with age. The research department at the company took a sample of 8 cars of this model and collected the following information on the age in years and prices in hundreds of dollars of this car. Question 1a. Estimate the regression equation, which is y equals to a plus bx. So for this question, since the price of this car is affected by age, therefore the age will be independent variable, which is x, and then the price of car would be dependent variable, which represent y. So the regression equation would be price of car equals to a plus b multiplied by age. So in order to obtain the value of b, you need to use the least square principle and then substitute into the formula, and after you do all the calculation, you will get b equals to negative 16.626. After that, same things goes to obtain a. You will need to use the least square principle to find the value. Substitute into the formula and you will get a equals to 150.412. So in conclusion, the regression equation would be price of car equals to 150.412 minus 16.626 multiplied by age. Question 1b. Interpret the value of b obtained in part A. So, after you have done finding the value of b in part A, you will find out that b is equal to negative 16.626. This indicates that it is a negative slope. It means that a and b are inversely related. In this case, when age increases, the price of car will decrease.
Question 1c. Estimate the price of a car which is 5 years old. From equation y equal to a plus bx, we can obtain the price of the car. From question 1a, we obtain the value b, which is negative 16.626, and the value a, which is 150.412. As we all know, y represents the price of the car and x represents age. When we substitute 5 into x, we can get the answer, which is 67.282 in unit $100.
Thank you, Jamin. Hi everyone, I am Shamimi and I will explain to you guys question 1D. Calculate the correlation coefficient between the age and price of the car. Subsequently, interpret its value. So for this question, we can make a table to make it easier for us to calculate it. So for column 1, x is stand for age and the sum of the x is equal to 42. For column 2, y is stand for price and the sum of y is equal to 505. For column 3, x minus x bar, which is x bar is stand for sample mean. And to calculate the x bar, we use the sample mean formula, which is x bar equal to the sum of x divided by n. N is equal to 8 because we have 8 data in the information given. So 42 divided by 8, we get 5.25. In the column 3, for the first data, 8 minus 5.25 equal to 2.75. For the second data, 3 minus 5.25 equal to negative 2.25. And for the rest of the data, we use the same method. And for the last data, we get negative 2.25. Next, for column 4, y minus y bar. Y bar is 10 for sample mean. And we use the sample mean formula to calculate the y bar. Y bar equal to the sum of y divided by n, and after we calculate it, we get 63.125. So in the column 4, for the first data, 18 minus 63.125 equal to negative 45.125. For the second data, 94 minus 63.125 equal to 30.875. For the rest of the data, we use the same ways, and for the last data, we get 35.875. And for the last column, open bracket x minus x bar close bracket times by open bracket y minus y bar close bracket. So for the first data, 2.75 times negative 45.125 equal to negative 124.09375. For the rest of the data, we use the same method, and for the last data, we get negative 80.71875. So the sum of the open bracket x minus x bar close bracket times by open bracket y minus y bar close bracket equal to negative 723.25. So to calculate the sample standard deviation for x, we use the formula as you guys can see in the slide, and we just take the data from the table and insert it into the formula, and we calculate it, and we get 2.4923. And for the sample standard deviation for y, we also use the same method, and after we calculate it, we get 44.895. So to find the correlation coefficient, we use this formula. R is stand for correlation coefficient, equal to the sum of open bracket x minus x bar close bracket times by open bracket y minus y bar close bracket divided by open bracket n minus 1 close bracket times by standard deviation, sample standard deviation of x times by sample standard deviation of y. So we know all the value from the previous slide, and we just insert into the formula and we calculate it, and after that we get negative 0.923. So the value of the correlation coefficient is negative 0.923. Therefore, the relationship between age and price of the cars is the inverse relationship, and it has strong negative correlation as the value of negative 0.923 is close to negative 1.00. In other words, we can say that if the age of the car increase, the price of the car will decrease because they have inverse relationship. So that's all from me. I will pass to the next presenter. Thank you.
Hi everyone, I'm Nazreen. Now I will be explaining for question 1E. Determine the percentage of variation in the number of breakdowns, which can be explained by the age of the car. Now, to know the percentage of variation, first we need to know the value for correlation of coefficient, which is R. From question D, Shamimi already explained the correlation of coefficient, which is R, is equal to 0.9232. Therefore, the coefficient of determination, which is R squared, is equal to 0.8523. In conclusion, the coefficient of determination is expressed as percentage. Therefore, 85.23% of the variation in the number of breakdowns, which can be explained by the age of the car. That's all from me. Thank you.
Question 2. A researcher wanted to study the relationship between gender and owning cell phones. She took a sample of 2,000 adults and obtained the information given in the following table. At a 5% level of significance, can you conclude that gender and owning a cell phone are independent for all adults? At first, we need to create a hypothesis, which is the first one, null hypothesis. It is gender and owning a cell phone are independent. And the second one is alternative hypothesis. It is gender and owning a cell phone are not independent. At 5% level of significance, we let alpha equals to 0.05. And by using the information that we have from the previous table, we get to know the observed frequency. So how do we get to know the expected frequency of men who own cell phone? So we need to use the total of men who own cell phone and do not own cell phone, which is 1090, times the total of men and women who own cell phone, which is 1080, divided by 2000. So we will get 588.6 and so on. By using all the values, we get to do chi-square test statistics, and the formula will be the observed value minus expected value square divided by expected value. So after you got all the values for chi-square, you will have to sum up everything, and the answer will be 21.4455. The alpha is 0.05, so based on the chi-square table, the critical value for x squared will be 3.841. So in conclusion, chi-square value is larger than the chi-square critical value. Therefore, we will reject the null hypothesis, and we cannot conclude that gender and owning a cell phone are independent for all adults.